Yes. So thank you, Professor Reddy, for the introduction. And again, thank you for inviting me to give this inaugural webinar for this academic year. And good morning, good afternoon, good evening to all the people who have joined from around the world. It was really nice to see, like I have seen on when the people were joining, as I was telling you, Professor Reddy, I saw people from whom I have interacted, taught, or worked with in all the different countries that you mentioned about. So, okay, so let's get started. And I would like to say in the beginning very clearly that I'm not an expert on this topic. I choose that topic because I thought that it would be nice to discuss this topic. So today's webinar is more of kind of a brain, like food for some thought, and then we can brainstorm together. So my target is to keep it in 40 minutes so that we can at least have around 20 minutes for Q&A and discussion. So let's get started. So as you heard about the title, Leveraging Artificial Intelligence for Circular Economy in Waste Management. We call it like a sustainable waste management. So we'll talk about briefly what they are to start with. So when we say like a AI, IoT, ML, different terminologies are used. So they, of course, there is a days have come now that we need to have integration of these advanced technologies, AI, IoT, big data in sustainability practices, and that's already kind of started to some extent. Uh, how it can be helpful? Of course, it can help in terms of optimize the resource use. It can minimize it to minimize the environmental impact. And then ultimate goal is to what achieve economic growth while preserving the natural ecosystem. So in this next 35-40 minutes, we'll try to see how AI could be handy in doing that. And we'll look at some of the case studies where they are already doing that and some like food for thought to how to go forward. So when we talk about this circularity, waste management, we all know that the world is becoming more and more urban. Even in the rural areas, we are seeing an increase in the waste generation. We are seeing the impact on climate change. If you, those of you who are from India or follow Indian news, whatever is happening, say in Jammu area right now, or even in Rajasthan. So we had like a very like extreme weather events are happening more frequently, not only in India, across the world, but we are seeing in India right now this week itself. So of course there is an impact on climate change. We have to use the resource effectively because we are going to be like more than 8 billion by the end of the century. We may be around 11 billion people, and the world is expected to generate around 3.4 billion tons of waste per year by 2050. Now, this waste, as you have, if you have heard me before, I keep on saying that this is not a waste. This is actually, it's a misplaced resource. So we need to come up with technologies, we need to come up with solutions to use this waste material back into the economy. That's where the circular economy comes in picture. We cannot have take, make, and dispose linear economy. And then let me get my pointer here. So we cannot have this take, make, waste like a dispose linear economy. Rather than we need to move towards circularity, where you take the raw material, you manufacture, distribute, use, dispose. So rather than disposing, you try to extend the product life. Redistribution you do, remanufacture, recycle, and reduce, reuse, recycle is coming. So how it will help? It has been documented well enough that there are technologies now out there in terms of resource recovery, which can help us reduce greenhouse gas emissions. And of course, we can have some, everything requires a good business model. So we can create sustainable business models and new markets. So we'll talk about these aspects in subsequent slides. So you may have seen this already. This has been there for quite some time now that we see that the world, right, this data is almost now 7-8 years old, where the 2.01 billion tons of municipal solid waste annually, and then it will increase to 3.4 billion tons. So, and if you look at what is there, variety of components, metal, glass, plastic, cardboards, food waste. Individually, if you keep the wet and dry as the government of India suggests, or if you are in Toronto or at any places, we do the food waste separate or other recyclables separate. And then if we can do that properly, we can actually recycle most of it, do resource recovery from most part. what is happening today is in many parts of the world, we are mixing the waste together. When we are mixing the waste, it's very difficult to do anything with it other than putting it in a sanitary landfill. So this is the last year's report. That data was a bit older, but the last year's report is also suggesting that world has to move beyond the waste era. This is the UNEP report on beyond an age of waste and turn rubbish into resource. So projections are showing that we are doing lots of open dumping. We are burning the waste, mostly open burning, and that is causing increase in pollution. Urgent need is required where the waste generation and economic waste generation from economic growth has to shift towards zero waste and has to have more circularity. Although we keep on talking about circularity for last several years, unfortunately, this past year our circularity percentage has gone down. Earlier it was around 9%, now we are down to around 7% circularity globally. So we need action. We are seeing lots of inaction on the global waste management area or resource management area that is impacting our human health, economics, environment, and then it can lead to almost $600 billion that it will surpass in terms of cost that is going to be for improper waste management by 2050. So we have to do better. So in terms of, if you look at very simply how we manage solid waste, either it could be a centralized approach or decentralized approach, and I'll show you how this AI, IoT, ML, and other things could be useful in both the sector. So we generate the waste, we store it somewhere, we collect it, we transfer and transport, process it, and dispose it. So centralized could be you have a big plant, especially, see, it all depends on economy of scale as well. So some of the aspect, like if you go for waste to energy and others, you need a certain size of plant. If you don't have certain, especially incineration plants. But if you talk about composting and certain other technologies, decentralization also works. It Land availability is also a question, and many times you need where you will find the land. So you may have to transport the waste at a larger distance. The transfer station comes in picture. So we have variety of components there. Could be you can use transfer station, incineration, composting, aerobic digestion. Finally, what cannot be done goes to the landfill. Decentralized approach also similar. You can have you can take few wards or few like part of the city and have a compost plant there. You can also have a biomethanation plant. Depending on, again, it all has to work. Economics has to work, and that's what is very, very important. So if the economics doesn't work, things are problematic. So as I said earlier, waste generation, we have waste, dry waste, sanitary repair waste as well. Special care waste has to be collected, transported, sorted, waste processing, treatment, disposal. And so this is basically in big picture, what are the different stages in solid waste management. So, so as I said earlier, say if you really want to have an effective waste disposal, segregation is the key. And some of you may have seen this slide earlier as well. I wrote this piece almost now 7 years ago. And unfortunately, still we are doing very poor in terms of segregation, not only in India, but pretty much many places in the world. So unless we do segregation, so how AI and IoT can help in segregation, we'll look at that as well. So, and the other component, the other phrase on the title was circular economy. Circular economy, I think by this time, most of us have some idea about circular economy. So circular economy is nothing but let's try to reuse the waste. Let's no waste actually to not to produce waste, because as I said, waste is actually also a resource as long as you have the technology to make it a resource. So rather than make waste linear model, you try to have try to design regenerative by design, decouple growth from the consumption of finite resources, and while doing that, you also look at how it is going to positively affect the society. And at the end of the day, because we have finite resource, see, whenever you look at any resource, it's kind of a finite resource. So we have to make better use of resource and try to design the waste out of the system. As I said, circular economy. Right now, the way we live, the world's only 9% of the world's economy is circular, which was again previous data. This latest data says it's down to 7%. The way we live, we need 1.8 Earth. Unfortunately, not unfortunately, but we have only one Earth. And of course, we are trying to go to Mars, but I don't, the way we are living on this planet Earth, I don't think we deserve to go to Mars. If you disagree, we can debate that during the Q&A and the discussion section. But I don't think we really deserve to go to any other planet unless we fix the mess on this particular planet at the first place. Uh, we are using 80% more of the earth resources that it can give us. So circular economy says that to extend the life cycle of product through sharing, leasing, reusing, repairing, refurbishing, and recycling, and try to make better use of resources which is available to us. So how this digitalization and industry 4 in circular economy can work, and which are the tools? So when I talk about leveraging artificial intelligence is one part of it, but AI is kind of, if you look at the other AI and the other tools available, see, we have AI and ML, which is artificial intelligence, machine learning. You have Internet of Things. In the next slide, I will try to explain a little bit more on what actually they are. Some of you may be aware, but since this kind of webinar is attended by a variety of people, so I thought I will give a little bit of background on that. Then blockchain technology, smart manufacturing. So if you look at artificial intelligence, machine learning, it can help in terms of predictive maintenance. So you extend the product lifespan. If you extend the product lifespan, means you're letting it not go to the waste stream for, and you're using it for a longer period of time. So that reduces, so in terms of reduce, it can help there. AI-driven material sorting, which already there are some plants in North America and Europe and other places where they are using AI-derived material sorting, which improves recycling accuracy. Supply chain optimization can be done, which reduces overproduction. Then you have Internet of Things, which you have the smart sensors. In fact, right now, today, actually, I'm sitting in Delhi right now because tomorrow morning I have to present my one proposal that I have written to. There is a national mission for Himalayan studies, where we are trying to use some of these IoT and AI stuff that I'm proposing to use along with my computer science colleague in terms of how we can do better management of plastic waste, especially in that Char Dham Yatra and our Jammu, as well as Jammu side, as well as also looking at Sikkim side as well. So, and we have collaborators from those places too. So there we will be trying to use some of these like a tracking of recycling, use of where the waste is ending from, so and where how the waste is moving through, so that we can understand the problem better. Unless we understand the problem, you cannot come up with the solutions to the problem. So there, how can you use this IoT and other stuff for that purposes? Blockchain does help in terms of transparency, traceability, from create a secure each record in terms of a state's product's life cycle from raw material to end of life. Then you can use track and manage waste stream, better sorting, recycling, and other stuff. Consumer engagement can also be done, can provide consumer with information about sustainability of product. As if you can keep transparency in the system, that becomes always better. Encourage responsible consumption. Then smart manufacturing is also coming in terms of additive manufacturing, 3D printing, reduces material waste compared to traditional machining. Closed loop smart factories are coming up where you use real-time data to optimize your energy, water, material flow, and all that. So in terms of when we say this AI and other stuff, what actually they are. So there's just one slide to kind of give you a little bit of AI and data science background. Artificial intelligence, they refers to simulation of human intelligence by machine, particularly computer system. And what it does, it enables machine to perform tasks like learning, reasoning, problem solving, and decision making without human intervention. So that's what it's a little bit of risky side there as well, but in some aspect, not always. So, and then you have machine learning where you have algorithms, what it learns pattern. So more the data you have, better data you have, better it will performance over time. So that's machine learning will learn from data and try to predict. Deep learning is kind of subset of machine learning, which kind of use ANN, artificial neural network, and it produces large database and try to understand the complex patterns in terms of image classification, speech recognition, and all that, and it helps you in that aspect. Then we have natural language processing, which it can help the machine to understand and interpret human language, like chatbots, language translation. Then we have computer vision, where you can have image recognition for interpret, analyze visual data. And then you have data and data science, which uses lots of statistics to analyze and extract insight from complex data sets. So these are the different tools which is out there. You can use this tool in different applications for environmental applications. So how to use them in waste management? How to bring circularity in waste management by using these AI tools? So part of it we kind of talked about earlier as well. So it does help in optimize collection route. Those of you who have done a waste management course or you understand waste management, you know that 60 to 70% of the waste management infrastructure cost actually goes in collection. So if we can optimize collection route, reduce operational cost, that will actually will help a long way in terms of the industry. And automation, if we can have automated sorting and detection, although it's not easy because the waste is so complex, the waste keeps on dynamic every few years, even I would say even sometimes every few months, new types of material keeps on coming into the waste stream. So it has to be that whatever we design in terms of automated AI powered systems, it also needs learning, relearning, sometimes maybe unlearning and relearning again. Forecast future waste streams and resource flow, that is predictive insight, so that you can plan for future. So that can be helpful. It can help in terms of better material design, manufacturing, use, disposal. Opportunities from data sciences there in terms of circularity in design, automated waste detection, route optimization, which we kind of talked about with preventive maintenance and all that too. So how AI can help in reducing waste generation? You can demand forecast. AI based on the previous data, as long as you have the good data. See, that's very, very important. See, none of these works unless you have good quality data. That also becomes a problem in many parts of the world, where we data which is there, we kind of, it's not really correct. So we need to have good quality data, then only these things are going to work. So you can predict production needs to reduce overproduction. If you don't have overproduction, that will reduce the waste as well. You can predictive maintenance based on how the machine is performing. If you can have the sensors and it can take those data, that it can predict that there is a equipment is going to fail, we can have a predictive maintenance and then that will help in terms of reducing the waste. We also in the defective production, it can make the production better. Design AI can analyze product life cycle in terms of eco-friendly design, reduce material use, optimize production process, consumer behavior insights. If you can, there are models now where you can track and analyze consumer habits so that we know in terms of their sustainable purchasing and waste reduction. AI can predict rate of product returns, so determine the condensed condition of the return items. Supply chain optimization as well. They identify supply chain to reduce resource loss and optimize material usage. Then in terms of predict waste generation, it can give us the waste volume using demographic data, seasonal data, behavioral data. As you can see, data. So unless you have good data, the forecast will not be good. Helps allocate collection resource efficiency. You can have a smart waste bins, which is already kind of used in many places in the world. Sensors in the bins tells you whether the it can help in terms of the collection network. It can analyze this data to schedule pickups only when the bins are near capacity, so on-demand collection. You can have a smart route optimization. You can have machine learning algorithm which look at the historical data, traffic patterns, waste levels, reduce fuel consumption, operational cost, also as well as carbon emissions. Real-time AI can adjust collection schedules based on traffic pattern, like our Google Map sometimes tells you to take the alternate route. Weather forecasts and also holidays time, minimize missed collection, optimize fleet utilization. Those trucks are quite expensive, especially those like a well-equipped trucks, they are expensive. So it can help in terms of material sorting and material recovery stages as well. So deep learning models, they can classify material through image, enhance processing in sorting hazardous versus recyclable item, distinguish between different plastic polymers. Automated waste sorting, we already kind of talked about. If you can sort materials like plastic, metal, paper, you can use robotic arm equipped with AI. And these things are happening, but it is a lot of challenges are there too. See, it's not that you can do that like this, because it requires lots of training, and waste being so heterogeneous, and so much of keeps on changing, as I said earlier as well. So you need to really have this robotic training is required, and you need a good data points to start with. Separate e-waste components, circuit boards, metals can be separated. You can have AI algorithm for optimized recycling process. AI can detects contamination in the recycling stream. Like if you have food residue on plastics, so you can better quality of recovered material. That means better money. AI is used in predictive maintenance as well, extend the lifespan, reduce the cost. So those things, as you can see, it can really help things becoming in the circularity. So if you look at some of the specific stuff, like in terms of if you want to use AI kind of tool in organic waste treatment options. So we throughout the world we want to have source segregation. Source segregation predominantly what we try to do wet and dry. Wet is essentially our organic waste. So you have organic waste, you can do anaerobic digestion, you can go for fermentation, you can go for compost, you can go for hydrothermal carbonization, pyrolysis, gasification. So variety of options could be there. So organic waste typically you will like 40 to 60% in something in Indian conditions. There are different thermochemical, biochemical processes are there. What happens is we have inconsistent source segregation. Inorganic waste leads to contamination. So if you have contamination, then compost quality hampers. Manual monitoring of our organic waste is slow, and it's so manual data collection is also often incomplete and inaccurate. So what we can do in terms of organic waste, we can have a smart waste classification and sorting. So we can look at in contamination in the organic waste, reduce the contamination, improve it. It will improve the compost and biogas quality. Can look at the composition as well. So if I can have a say where AI can analyze my organic waste composition, and it can tell me whether I should go for composting or biogas. It can also tell me whether should I go for a pre-treatment step, or how much pre-treatment is required. So that will really help. Real-time feedback could be done to enhance the quality of the process. Real-time process monitoring, as I told you, organic waste decomposition process. So we can tweak IoT sensors could be there, which can look at the temperature, moisture, pH, and all that. Even you can, in terms of prediction of how much gas will be produced, oil will be produced, char yield could be there in terms of thermochemical process, predicting the biogas yield, process stability. So if we can design it properly, these tools could be helpful in making this organic waste treatment more effective. And people are working on that already. You can see some of these papers which I have cited over here. This is a review paper which looked at the variety of papers there, where they are looking at on the waste prediction in terms of ANN, mostly ANN here. Then they are also looking at the route optimization, bin level detection, waste classification. So there has been application being demonstrated through some pilots and other things. And there are some plants which are still started using these too. For example, they have a smart waste management in Barcelona, where they have a smart waste management system. There are other places too. I just picked few examples just to illustrate this point, but there could be a variety of examples out there. I've seen in Netherlands and some of the Western European countries by myself. So they have a smart waste management system that utilizes sensors installed in waste bins. They monitor the fill level and they communicate with the waste collection truck. And that helps in better collection routes based on real-time data. In Seoul, Korea, in South, they have a intelligent waste management that combines sensor technology, big data analytics, as well as citizen engagement. So there are RFID tags attached to the waste bins, allowing the city to track and monitor the waste collection in real time. So then this one of these sorting that is happening case study, which is happening in Virginia. One recycling center in Virginia that installed this AMP technology, which AMP is AI platform. AMP Neuron TM uses cameras to scan mixed waste and identify the different materials. And by installing that, they actually have improved their recycled material increased by 10%. So that's it's not that it's just a fancy technology. It has the real application on ground too. So Neuron's deep learning capability allows for continuous improvement. But here, one thing you need to have is you need to have at least wet and dry segregation. You need to have recyclables collected separately. As you can say, source segregation cannot be replaced. Even with AI and all that, you will have to do source segregation, which is actually one of the bottleneck in country like India. But we have to do that. Then these things is going to work. So you can categorize for paper, plastic, metals, different colors, different size, different shapes, sometimes brands, ability to classify more than 100 different categories. So there in this is the case study happening in Virginia. Similarly, there is another one which is in Ohio, in Solon, Ohio, which AMP Robotics Corporation, they are operating it. So they are using AMP jet technologies, which is pneumatic ejectors, computer vision, AI cameras are there, which is looking at color, texture, logos. Machine learning algorithms are being used, 150 billion objects. So annual capacity is 58,000 tons of waste, where 18 tons per hour. Sorting efficiency is more than 90% recovery rate for targeted recyclables. So it does help. See, initially they are costly, of course, but as you use it, your return of investment may be slightly longer. But if you think from a life cycle cost, see, we have to think in a life cycle cost as well. Of course, many times in the industry, we think only the short-term cost. But if you think of life cycle cost, better resource efficiency and all that, so these things does help globally. And of course, these things also needs to be supported by some sort of, I don't want to use the word subsidies, but some sort of incentives for these companies to really like come forward, because of course they are a bit costly to start with. In Sweden, they have a state-of-art plastic sorting plants where they're using NIR sensors, they're using deep learning cameras, laser object detection, digital process. Here also they have a purity level of more than 90% for the monoplastic fractions. Sorting efficiency is up to 95%. So they are these things are being used, and these things does help in terms of bringing circularity. But better, like we talk about all these stuff, but what are the challenges, which I think we already kind of looked into? Data quality, data availability and quality issues. We right now, if you have inconsistent data, fragmented data, limited data in informal sector for a country like India, where most of the recycling is happening through the informal sector, unreliable reporting practices also, lack of a smart waste infrastructure. For example, many cities in India people have been given two bins in wet and dry, but the truck still does not have the compartments. So if the truck does not have compartment, they mix it in one truck together. The separate truck doesn't come. So then people lose the incentive to do the source segregation at home. So if inefficient waste segregation at source, poor waste processing facility, so those things has to be worked into. Then high implementation cost, lack of incentive for private investment, informal sector dependency is there, policy framework needs to be there, weak enforcement, data privacy concern is also there in when we use all these different tools. So when we talk about all these different AI and other stuff, one thing which I say that, see, these are, if you think about like if you uh, to make a comparison with a pizza, like a pizza is, we all love pizza, most of us, and especially since this is being hosted from Chicago, that Chicago deep dish pizza I really enjoyed with Professor Reddy when I was there. So in terms of pizza, you look at it, it has your base, then it has cheese, then you have some toppings, and you add some seasonings on the top. So your, unless you have good quality waste collection infrastructure, that's your base, and then your all those trucks and other stuff, segregation, that's your cheese. And cheese and bread has to be, if the cheese and bread is not good, whatever topping you've put, it's not going, your pizza will be is useless, you will not enjoy that pizza. So these toppings, like all these could be your all these different technologies which is there, including AI, and then you can put all these toppings, but your base stuff, base of your good practice in terms of having a robust waste management infrastructure, that is required, which you have proper trucks, proper collection system. Of course, you can use this AI and other stuff to make it better, but unless you have those proper stuff, these toppings are not going to be useful. So then you have, okay, this was the waste sector, but the circularity that is also being used in the, I'll give you next 3-4 slides and I'll stop so that we have a good time for Q&A and all that. So there are application of AI and automation in the water sector as well. People are looking at in terms of contaminant detection, real-time monitoring, water quality. In fact, early 2000s, when anthrax was there, that time, that from that point onwards, people have started talking about like a online detection of certain contaminants, certain contaminant, or could be some sort of like a like antisocial elements trying to disrupt certain water sector and all that. So those things also in terms of safety was also was looking at. So real time monitoring, we are using it for process optimization, water quality. and non-autonomous systems development, and also water resources management. So AI in water control and treatment has actually developed quite a bit. So there are tools used in terms of real-time water networks management. So it gathers information from many sources like sensors and database, and try to use it in terms of try to look at the leak which is happening, which is one of the major problem in water supply systems. And then water quality monitoring as well. So for example, if you look at the disinfection byproducts, which is again another cause of concerns we have. So if you want to predict disinfection byproduct from water quality parameters, pH, temperature, organisms, so we are using AI tools, includes your ANN and other stuff. Then we can use AI enabled real time water monitoring system as well, in terms of sensor data, dashboard alert could be there, automatic gate adjustment could be there. So AI driven real time water monitoring framework, such as, so that will be really useful. In fact, even for flood protection, I would say Singapore is using a smart water grid, where they are known. Of course, Singapore is known for its advanced water management practice. Now they are using AI-powered smart water grid. So utilize sensors and AI algorithm to monitor real-time water quality. And then Singapore, as you know, they take the wastewater, they treat it, and then the treated wastewater is taken to the drinking water plant, and then they use it as a re-water. So system, they have been doing circularity in water for many years now. So system promptly identifies any anomaly, potential contamination, so you can intervene. So smart water grids, rapid response to water quality issues. So make sure the safe drinking water is supplied. So and then if you can do that, you also there is a trust builds between the consumer and the supplier, that we don't need all those RO units that we install at our home. See, our all these RO that we install our home is kind of as an environmental engineer. Although I have an RO in my home at IIT Kharagpur campus, but I feel like it's like a waste way, because the kind of water we waste and all that. So in terms of optimized coagulant dose, replacing jar test, turbidity, natural organic matter removal efficiency, you can do for membrane fouling. So you can have a machine learning stuff in there as well. So those things are being used in other sectors of environmental engineering as well. In fact, to predict heavy metal removal, to model equilibrium adsorption process, disinfection process, all those things are being done. So when we talk about this AI, so what are the challenges? Some data-wise, we talked about the challenge for waste management, but in general, if you talk about civil engineering, I thought civil engineering application, if AI could be used in other civil engineering applications as well. So need for civil engineers to be proficient in data science and AI concept. So the way we teach to civil engineers also needs to actually look at. We have to talk about high initial investment, cost of software, hardware. But when I talk about this civil engineering curriculum, I don't want our basic courses to go away, huh? Because those basic courses are needed. That again is the pizza example can be given. All those basic courses, your electives, and then you can have your AI and those courses there. Because unless you are a good civil engineer, just having knowledge of AI is not going to help you. But in today's world, you have to learn all this stuff as well, because this is how uh, the entire global industry is moving towards. So we should be aware as a civil engineer about this different technology which is out there, and how to use it in civil engineering application. And we can use it in civil engineering application when we know civil engineering. We have to really be good at basic civil engineering as well. So data quality AI models are only good as the data they are trained in. Then of course data privacy, cybersecurity risk is there. There is a cultural resistance always. There is overcoming traditional practice within the industry. Regulatory liability, who is responsible if the AI design structure falls? And then of course the skill gap which I talked to you about. So there is always also, I thought I will the people are always worried about, will the AI will take away our job? I don't think so. We need to basically evolve. There has to be an evolved role of civil engineer. See, past we were focusing on manual drafting and calculation. Present we focus on design and analysis. We use software like BIM and other softwares. Future will be more focused on integration, oversight, innovation, bringing sustainability, circularity will there. So this is always a for fear when we have a technological revolution. Every technological shift has transformed jobs, not eliminated them. The calculator did not replace mathematicians. It allowed them to solve more complex problems. So models have allowed us to do better things. We have to upskill, learn the principles of data science, machine learning, and how to work with AI tool. You don't need to be a coder, but you have to be a literate in terms of these subject area. Focus on soft skill as well, critical thinking, communications, where humans have permanent advantage. I don't think they can replace stuff. So just to that's what on top big picture of what I wanted to cover very quickly in next 2-3 slides. I will just talk about what we are doing right now. So we are trying to use lots of circular economy kind of stuff in our lab. We are working a lot with organic fraction of municipal solid waste for fuel application, energy storage application, try to produce bioplastics, and to bring circularity, even hydrogen production. We have a project where we are using food waste along with sewage sludge for our biohydrogen production. Then we have a Indo-Sweden project where we try to learn from each other in terms of bringing circularity in municipal solid waste and all that. And recently, we have a couple of students who are trying to work on how to use AI and other tools in terms of uh, better, I would say, process of life cycle assessment, for example, and also with better waste management. As I told you that tomorrow I have to try to defend a proposal in front of a panel. I hope that we get that proposal, get that project, where we are trying to use AI and IoT and other sensors and other tools in terms of better plastic waste management, especially in hilly areas of India, both in Jammu area as well as in Sikkim area. We have the two areas that we have identified. So we are working with my variety of organic waste. So if you have learned me before, you have seen that. As Professor Reddy was mentioning at the introduction, I have developed several online courses which is available on YouTube. It keeps on being offered through Siam NPTEL platform. So there's a course on sustainable engineering concept and life cycle. I'm trying to develop a course on circular. I call it a circular engineering. So very soon you will have a course on introduction to circular engineering, because I do feel that without thinking unless the engineers start thinking in a circular way, you will never have circular economy. So waste management and then plastic waste. We have course on e-waste and the basic course on environmental engineering as well. And I do work with several startups in terms of this is a voluntary service we provide in terms of helping them to fine tune their work. Of course, we sign non-disclosure agreements and to help them do better in terms of their business prospects. So you can always contact me. This is my group. This is slightly, many of these students have already graduated. And then this is the present group. Just 2 days ago, we took this picture when one of our student was leaving the group. So thank you. And if you have any questions, we'll be happy to take now. So that's it from my side. And I hope it
Yeah.
was useful. I just wanted to, as I said, it was more for food for thought rather than so
Yeah.
so that we can debate on these aspects.
No, thank you so much. I think, these days, everyone has to know how AIB is being used in every sector, but, you have highlighted